Welcome to Lesson 7 on Lewis dot diagrams. Our lesson objectives: construct Lewis dot diagrams for atoms and construct Lewis dot diagrams for ions. Lewis dot diagrams are different than Bohr diagrams in that they only show the valence electrons. These are the electrons located in the outermost shell, called the valence shell, and they are the last number on the electron configuration, listed on the bottom of your element box on the periodic table. So how do we draw these Lewis dot diagrams? Well, the first thing you do is you draw the element symbol as indicated here with this X. You're going to locate the valence electron number, that's that last number in the electron configuration. And you're going to give out one electron to each side of the symbol, representing the number of valence electrons that you have. Once all sides have one valence electron, if you have more, then give another to each side. So let's see an example. If you want to construct the Lewis dot diagram for carbon, I locate carbon's element box. I locate the last number of the configuration here, which is the valence electron number. So carbon has 4 valence electrons. I'm going to start by putting one dot at the top for one valence electron, then 2, then 3, and then 4. So I'm giving 1 to each side, and I'm working clockwise. And that is the completed dot diagram for carbon. Let's see another example for oxygen. Same thing, I locate the valence electron number. In this case, oxygen has 6 valence electrons. So I'm going to start at the top and give out 1 electron, then 2, 3, 4, and then I go back and repeat. So 5, 6. So that is the completed dot diagram for oxygen. And lastly, let's try one for aluminum. I locate aluminum's valence electron number, which is 3 valence electrons, and I'm going to dish out 3 valence electrons to my symbol. 1, 2, 3. Let's check your understanding. Can you construct Lewis dot diagrams for atoms? Now let's look at constructing dot diagrams for ions. Recall that ions, unlike atoms, are not electrically neutral. They carry a charge, which means they've lost or gained electrons. So how do we construct these dot diagrams and show that they're ions? Well, we take our diagram and we put brackets around the symbol, and we're going to put the charge, as indicated here in these two examples, in the upper right hand corner. Charge is the charge of the ion. And lastly, all of the positive ions, doesn't matter what it is, are going to have no dots around the symbol, indicating that we've lost electrons and formed a positive charge. And all the negative ions are always going to have 8 dots around the symbol, indicating they gained electrons to form a negative charge. So let's see some examples of that. Let's look at an example of a positive ion. So all positive ions will look very similar to this, except for the fact that the symbol and the charge will be different. So potassium has 1 valence electron. And here's our configuration, 2881, coming from the bottom of our element box. So the atom would have 1 valence electron, as indicated here. So to show that this is an ion, we put brackets around the symbol, and then to indicate that this valence electron number has been lost, we take away the dot, indicating that now, since we've lost an electron, we now carry a positive 1 charge, and I put that in the upper right hand corner of my symbols outside my bracket, so plus or plus 1, again indicating that loss of that 1 valence electron. So all positive ions will look very similar to this. It will be a symbol, no dots, your bracket, and then the charge of the ion. Let's look at a negative ion. So for the sulfide ion, sulfur has an electron configuration of 286, indicating 6 valence electrons in the valence shell. The negative 2 indicates that it's going to gain 2 electrons. So we put our symbol, we have our brackets, and now we're going to add 2 electrons to our symbol here. And now we have 8 dots representing the 8 valence electrons. Because we gain 2 electrons, we carry a negative 2 charge. We put that charge in the upper right hand corner. So here is the last example of an oxide ion, which is still a negative ion. Here is the configuration 2-6. So we would have 6 dots going around our atom. It is now an ion. We recognize that by the charge. So we put brackets around our symbol. And the negative 2 charge indicates we've gained 2 electrons. And so now I have a configuration of 2-8. I'm going to add my 2 extra electrons that I've gained. Because I gained those and they're negative, I now carry a -2 charge, which I put in the upper right hand corner of my symbol here with brackets. So let's check your understanding. Can you construct Lewis dot diagrams for ions? At this point, you should be able to construct Lewis dot diagrams for atoms and construct Lewis dot diagrams for ions.